Hello everyone, welcome to Pratibha Tech. In this video, we will solve the problem of the day question on GeeksForGeeks for 13th April 2023. The problem statement for today is partition the array. This problem is based on binary search and two pointers algorithm. Let's now open this problem to solve it. Let's go through and understand the given problem statement. Here it is said, given an array of n integers, the task is to partition the array into 4 non-empty contiguous subarray, that is PQRS, such that each element of the array should be present in exactly one subarray. Let W, X, Y, Z be the sum of the elements in PQRS respectively. Find the smallest absolute difference between maximum and minimum among W, X, Y, Z. Okay, so here it is said we will be given an array and we have to partition that array into 4 subarrays, and those subarrays should not be empty. Okay, and the condition is that each element should be present in only one of the subarray. There could not be any repetition. And within the subarray, let us assume W, X, Y, Z. These are the sum of all the elements of all the subarrays. We have to find the smallest absolute difference between maximum and a minimum among all of these summation. That means the whatever the variables are there which is indicating the sum of all the elements of the subarrays, that is W, X, Y, Z. Okay, so let's go through the given examples. So the first example says the size of the array is 5 and the array contains 4, 2, 2, 5, 1. So here the output is 4. So we can partition the array into PQRS like this. 4, then 2, 2 can be placed in one subarray, then 5 and 1. Okay, so here we can see that in the none of the subarrays is getting the elements repeated. That is 4 is there in 1, this 2 is there in 1, 5 is there in 1 and 1 is there in 1. And if you try to find the sum of all these subarrays, so W will be 4 because one element is there. X is also 4 because two elements are there with value of each of them is 2. So the sum is 4. Sum of this is 5 only and sum of 1 is 1 only. So the maximum difference is this 5 minus 1 is equal to 4. So that means, so what we have to do, we have to find the maximum of all these and the minimum for all these. Then we have to find the difference. Okay, so let's go to the second example. Second example says n is equal to 4 and array is given as 4, 4, 4, 4. So here the output is 0. There is only one way to partition the array and that is 4, 4, 4, 4. So if you take the absolute difference of any of this, then it will be 0 only, because 4 minus 4 it will be 0. Okay, I hope this problem statement and both of these examples are clear. So the logic which we'll use for solving this problem is to find the minimum absolute difference between the maximum and the minimum sum of the 4 contiguous subarrays, that is PQRS, such that P and Q and R and S are non-empty and P union Q union R union S, that is all of union of all these subarrays should contain all the elements. So this was the given in the problem statement only. To achieve this, we'll first calculate the prefix sum of the given subarray in an array called prefix sums. Okay, then we'll loop over all the possible indices from I is equal to 1 to n minus 2, representing the end index of P subarray. For each such I, it calls get min max sum method twice, once to get minimum and maximum sums of Q subarray, that is from beginning of the array to I plus 1, and second call will go to that method, that will get min max sums to get the minimum and the maximum sum of the S subarray, that is starting from I plus 2 to end of the array. Okay, it then calculates the maximum and the minimum sums of P and Q subarrays, which are simply the sum of the entire array minus the sum of Q and S subarrays respectively, and calculate the absolute difference between maximum and the minimum sum of all subarrays, it updates a variable called smallest difference to the to store the minimum such absolute differences seen so far. After all iteration, it returns the value of the smallest difference as the answer. Okay, so using this approach only, that means we will be calling that method get min max twice, and we will try to find the minimum and the maximum of a one window element. That means here we will be using two pointers here. One will be pointing to starting of the array, and another will be pointing to somewhere in between. And for each window location, and which will be updated in each iteration, we'll try to find what is the maximum and the minimum sum there. And if we get something maximum minimum sum which is smaller than the previous one, then we'll keep on updating that. Okay, so let's try to understand this approach with the example. So here I have taken here, I hope this is visible. Let me just increase the font size as well a bit. Font size 18. Oh, it's become too large. 14. Okay, yeah. So here I have taken the first example only. So if you try to calculate that prefix sum for this, then it will be 0, then 4, then 6. See exactly how to calculate the prefix sum is that take the element at once and add it to the previous one, and store it at that particular index. So initially this prefix sum was pointing to 0. So for array, so for index position 0, the sum will be 0. When we move to the next one, then it will see when it will move to the first index of this array A, then here it will try to add 0 plus 4. So it became 4 here. Then in next step it will add to the existing value of 4 to plus this from the plus the next array element from this array, next index element from this array. So it will be 4 plus 2, it will become 6. Now the value of 6, to this we will add this 2, so it will be 8. To the latest value of prefix sum, we add the next array element, that is 5, so that was 13, and here at last it will be 1 is there, so 14. So what it is happening here, see this array contains 5 elements, but here it is containing 6, because for the first element the previous element was 0. That means initially it was initially it was mentioned as 0 only. That means we have set the initial value of prefix sum of the first element of the array of 0 will be 0 only. So we are adding each of these values and we are storing in the respective place. Okay, so initially we set the smallest difference variable to 14. That means the maximum of this prefix sum. So it was 14. So we are storing it to 14. So now we will call get min max sums for window size 1 and 2. That means we are starting from 1, and we are taking one position at a time, this one, and we will pass prefix sum into this method. So inside this one we are setting the minimum sum for all iteration to 0 only, and the maximum sum will be the index position of this maximum here. So here, since we had passed 2 here, so if you look at this array, then what is that maximum value? What is the value at this index position? Index position 2, it is 6. That's why it is 6 here. Okay. Then we calculate left and right sum using this binary search. So if we take this the element this 4 and 2 here, this one, and since this array is starting from this 0 position, so if you are taking this window location here, so we can see that if considering this as the mid here, then 4 minus 0 is 4, that is left sum, and from the mid to the right the sum is 2. That means 6 minus 4, that will give 2. Okay, so what we are doing, for the left one we are calculating mid minus left, and for the right we are calculating right minus mid. So we get the value 4 and 2 here. Then we check this condition. If absolute value of right sum minus left sum is less than maximum sum minus minimum sum. So max sum minus min sum, we have all these four variables here. So we see that yes, right sum was 2 and left sum is 4. Absolute value it will give us 2 only. Okay, and we can see that this is less than 6. That means max sum minus min sum, that is equal to 6. So this is less than this first expression is less than the second expression. So that's why in that case we update the value of min sum to whatever we have got in this step. So actually we have to find the minimum absolute difference. That's why we are trying to find the maximum, the minimum difference in each iteration. So we update to this one. So this will be our first call. Okay, so actually this will continue internally till left. That means in for a binary search we have two indices there, low and high. That means left and right. So till the point left is less than or equal to right, we perform this operation. But for this one, we see since the middle is pointing to this one only, and if you are decrementing any value for the high, then the condition will not be correct. That's why it will come out of this this method. So after calling the first time in this method, first time we got minimum sum and maximum sum as 4. When now we have to call it for the second time. Second time for which window size? Initially we have taken care for 1 and 2, this much, 1 and 2. Then now we have to take care for the all remaining elements. And this will keep on changing. That means next time that it will be pointing from starting to some more location, and second will be from subsequent array position to the end of the array. So now second time we are calling for 3 and 5. So here the same way, minimum is again set to 0, and maximum is 14 minus 6, that is equal to 8. So here maximum was 6. How it was? 6 minus 0, that's why we got 6. Here we have to here maximum we are getting as 14 minus 8. Sorry, 14 minus 6 here. 14 minus 6 here, that's why we are getting 8 here. Okay, so we have to calculate that from the highest value to the minus the lowest value of that window. So we get the maximum. Now we try to calculate the left sum and right sum. So here we will get the mid position as 3. So if we try to calculate the left sum, so it will be mid minus left, that is 8 minus 6, that is equal to, and right sum it will be right minus mid, since the mid is at mid is pointing to 8. So we get 14 minus 8 is equal to 6. So here again we check left sum minus right sum minus left sum. Is it less than the max sum minus min sum? Then again we will say yes, because here max sum minus min sum was 8, and here this was 4. Since it was 4 and it is less than the maximum and the minimum sum value, then we update the min sum to 2 and max sum to 6. That means whatever we are getting from this left sum and min sum, that we are updating to this. Okay, so similarly this will calculate here also till that condition becomes invalid. So after that, once we come out of this loop, then what we do, we get this one. Here we can see we have got two minimums and two maximum values. So what we do, we calculate the absolute difference between these two values. So math.absolute of math.max, that was 4 and 6. What were the 4 and 6? What are the maximum sum value from both these methods? So one time we got 4, second time we got 6. So we are taking the maximum of that, and to this we will subtract math.min of 2, 2. What is 2, 2? 2, 2 is the minimum sum from both these methods. So that we are doing here. So we are getting here the difference as maximum of 4 and 6 is 6, and minimum of 2 and 2 is 2 only. So again, so that we have got as absolute difference. So absolute difference will be 6 minus 2, that will be equal to 4. Now the smallest difference, you remember initially we had initialized a smaller difference to the 14, the value 14, that is maximum in this prism array. So now we are checking whether that was small or whatever we have got the absolute difference is that small. So for that we compare math.min of a smallest difference and absolute difference. So here we can see if we try to do math.min of 14, 4, then we get 4. Okay, so this was for one iteration when the window size started with 1 and 2. Okay, so it will so in the subsequent iteration also the window size will increase, and it will move one pointer to the right, and it will continue. But even then we can find that we absolute difference whatever we get, that is 4 only. Okay, so this was the one iteration of it. I just tried explaining the algorithm for that how it works. So based on that only we have got the answer as 4 only. If you try to perform this operation in subsequent iteration, we'll get the 4 as output only, same operation. Okay, so I hope this whatever I tried explaining, that is clear. So now let's try the coding part of it. So I've already prepared a solution just to save time in typing. I'll paste it here. This is Java code. Okay, so I'll explain it line by line that what is happening in this entire code here. So to solve this problem, we first calculate the prefix sum of this array. Prefix sums are used to find the sum of the array in big of one time. We calculate the prefix sum of the array from 1 to n. Then we iterate over all the partitions. But before that we are initializing the smallest difference to sum of all the elements. That we are initializing it as the smallest difference. Then we iterate over all the possible partitions of the array into 4 contiguous subarrays. We use 2 loops for this partition. That means we are using this loop and we are calling this method twice. So we are iterating from I is equal to 1 to I less than n minus 2. Okay, so and here we are calling this method twice, as I have shown this in this example, that first it was called for 1 and 2, and next time it was called for 3 to last. So we are calling this method twice to calculate the minimum and the maximum sum of P and Q, and this was for the maximum minimum for R and S. Then once we get this value there, then we try to find out what is the maximum and minimum from both these pairs. That means min max pair, that is a custom class which I have defined, which contains min and max here. So the way we were looking at this example, that each response will contain min sum and max sum. So each time we get min sum and max sum both. So here we have to take the calculating the absolute difference, we are taking that math.max of all the max elements there, and minus math.min of all the min elements from both the objects. So for that only this operation is done. That means these four variables, we are taking the min from both and max from both, and that we are doing math.absolute of math.max of both the max minus math.min of both the mins. Okay, and that we get the absolute difference. Then we check, is it the minimum or the smallest difference in the previous step, that was the minimum. So whatever is the minimum, that will get updated here, and finally we return the smallest difference. Okay, and what happens inside this method, get min max method, is the same thing whatever I have explained while explaining that example. So again we'll get this left and right here. So we initialize the pointer low and high to for the binary search. Low will be initialized to left, and the right high will be initialized to right minus 1, because we are passing here this one. In this case we can see we are passing n only, that means the size of this one, but the array indexing works not with that high index. That means it will be 1 less than the size of the array. That's why we are taking the high as right minus 1. Then we initialize the mean and the max sum to the minimum or the maximum of the prefix sum of the entire range. You remember that entire range, whatever we talked here, this one. First time range was this, so minimum was 0, maximum was 6 minus 0. Next time when we went for this, then the minimum was still 0, maximum was for this range 14 minus 6, this range. So that's why we got 8 here. So we are calculating for this entire range. How we are setting minimum sum will be 0, and maximum sum will be prefix sum of right minus prefix sum of left minus 1. Then we perform binary search to find the minimum and maximum prefix sums for this range, and this will continue till the point low is less than or equal to high. Then we calculate the mid, then we calculate the left sum. Left sum, the way again I have showed here, I have shown here that the left sum will be here. That means whatever is your mid position minus left, that will be for your left sum, and right value in that range minus mid, that will give you right sum. Same thing is done here. Left sum is mid, prefix of mid minus left range, and for right it is right minus mid. So we get left sum and right sum. Then we check this in that condition there. Is that absolute difference of right sum minus left less than max sum minus min sum? This one. If that is the case, then what we do, we update the minimum sum value to minimum of left sum and right sum, and the maximum sum value to the maximum of left sum and right sum. Same thing we did here. So whatever we had got, if the condition is true, then we set minimum sum to the minimum of these two. Minimum of these two means minimum of 2 and 6, that will be 2, and maximum sum will be set to 6. So, and after this, if the left sum is smaller than the right sum, then we move the low pointer to the right of the midpoint, and otherwise we move the high pointer to the left of midpoint. That is for creating a new midpoint. So this condition will be running till low is less than or equal to high, and once this iteration ends, then we get the updated minimum and the maximum sum value, that will return as this pair here. Okay, and that only was returned to here in these two variables, and so these two objects, and we got maximum and min from both these objects. We compare the absolute difference, then we found the smallest difference. Okay, that's it. This was related to the coding part of it. Let's try compiling this code. So here you can see we have got correct output. So let's try submitting the solution. So here we can see it has covered all the test cases. So this problem has been solved successfully using Java as of now. Okay. So talking about the time complexity of the solution, it is in the order of n log n. The Prism array is constructed in big O of n time complexity because it is iterating over the entire array once. The outer loop runs for n minus 3 times. That means this one, yeah, it started from 1 and it ended with n minus 2. That's why it is running for n minus 3 times, which is big O of n time complexity. The get minimum sums function is called twice. It's called twice, and each call takes big O of log n time complexity, because we are following the concept of binary search inside this method. That's why it is taking big O of log n time complexity. So the overall time complexity will be big O of n into 2 into big O of log n. Why it is 2? Because we are calling this method twice. So it will be in the order of big O of n log n only. So this was the Java solution. Let's try to give this same solution in C++. So let's move to C++ editor. Minimize it. So I'll copy this C++ code here. So here again the logic is completely same, only the syntactical difference whatever we have between Java and C++, so that only is there. And here I've just removed the comment so that it becomes more easy to understand and visualize. Okay, so this is that C++ code for it. Let me try compiling this code. So here we can see even for C++ code we have got correct output. Let's try submitting the solution. So here even this C++ code is working fine. So this problem has been solved successfully using both Java and C++. Okay, so I'll provide the link for this question and even the link for this solution in the description box. Please do check that. That's all in this video. Please like, comment and share the video, and please subscribe to the channel for more upcoming videos. Thank you for watching.